I'm doing chemistry here all by myself. Oh, wait a minute. Who's that?
It's just Lord Poobah. So.
All right, Martin and I are doing the practice problems for Module 11, which are found on page 382. Okay, please read us number 1, Martin.
Hot tubs generally contain water at a temperature of 38 degrees Celsius. In order to keep the water clean, several solid solutes are dissolved in water. Try saying that 5 times fast. Many hot tub manufacturers warn that if the water gets too cold, it will get cloudy and filled with a fine solid. Why? Ooh, I know.
Tell us, Martin.
It's because if it gets cold, then like the solubility will decrease and they'll like condense back into solids.
Correct. So when they're dissolved in the water at a certain temperature, because solid solutes are affected by temperature, increased solubility. So if you lower the temperature too much, you might end up with unsoluble solutes. Sorry, there's a lot of chalk dust in the air. That's what's floating across my screen. It is not aliens or ghosts. It's just chalk dust.
That's what they want you to think.
Number 2, please.
If you have an open glass of soda pop sitting on the counter, it gets flatter than the same open glass of soda pop that sits in the refrigerator. Why?
This is the same type of thing. This is a solubility question. So in number 2, the solubility of gases is affected how?
Pressure and stuff.
Right. It's affected by gases and temperature. Okay. So what happens to the solubility of gases when temperature goes up?
It decreases.
So if the temperature goes up, the solubility goes down. If the temperature goes down, the solubility goes up. So the glass in the refrigerator has a colder temperature and a higher solubility than the glass on the counter, which has a higher temperature and a lower solubility. Does this make sense?
Yeah.
Excellent. Number 3.
The following reaction is performed in a lab. 3Na2SO4 aqueous plus 2Al open parentheses NO3 close parentheses 3 aqueous yields Al2 open parentheses SO4 close parentheses 3 solid plus 6NaNO3 aqueous.
Okay, what kind of a
if 345 milliliters of 125 molarity aluminum nitrate is added to an excess of sodium sulfate, how many grams of aluminum sulfate will be produced?
Okay, what's this first substance? Na2SO4.
Sodium nitrate, I think.
Oh yeah, with sulfur and oxygen?
Maybe.
This is nitrate?
No.
Look at it.
The other one's nitrate.
It's called sulfate. Sulfate. Where can you find the polyatomic ions that you need to have memorized? They're on page 288 in Module 9. You must know these polyatomic ions. You must have them memorized. All of them. Okay?
It's sulfite.
No, it's SO4.
Oh.
You're mistaken. Ha! Mother wins yet again. All right, so we've got
I'll get you next time.
Sodium sulfate plus 2 aqueous plus 2 Al. What's this? What's AlNO3?
Oh, that's aluminum nitrate.
Aqueous yields Al2SO4 solid plus 6 NaNO3 aqueous. Okay, so here's what we know. We know how many milliliters of AlNO3 we have, because that's what?
Because
That's the
that's
aluminum
aluminum
nitrate that they're talking about. And we know what what's this M stand for?
Molarity.
Molarity, which is what? Number
of moles
of moles per number of liters. Okay. We want to find out how many grams of this solid we're going to produce, right?
Yeah.
That is the aluminum sulfate. Okay, so we want to know how many grams. So this is a stoichiometry problem. Martin, if I use 2 moles of aluminum nitrate, how many moles of aluminum sulfate do I produce? Please look. If I use 2 moles.
I am looking. It's 1.
Right. So if I use 10 moles of this, look please, how many of this do I produce?
5.
What if I use 7 moles of this? Look please.
And you get 14.
Yeah. So that's all I'm doing. I'm just figuring out what is the relationship between these. Now I can use all of this to find out how many grams. Okay. So what is this? Let's convert this milliliters to liters. That's our first step.
So it's 0.345 liters.
Okay. So in order to find the number of moles, right, we're going to say molarity equals number of moles per number of liters. So if we know the number of liters and we know the molarity and we want to find the number of moles, it's going to be the what? Okay. No, I don't want you to get a calculator. I want you to tell me how to set this up algebraically.
Right. But we will need the calculator. So let's see. That's switch it around. So it's
Just ignore this for now. Molarity equals number of moles per number of liters.
Yeah.
The number of moles
is liters per molarity.
That's not true.
Okay.
You mean you're
Molarity
dividing?
Per liter.
Stop. What am I going to do? Look, if I have x equals a over b, and I want to solve for a, a is what? X times b.
Right, that's what I meant to say.
Okay, but that's not what you said.
Yes, I know.
So please tell me how to set this up algebraically. The number of moles equals molarity times the number of liters. Okay, so the number of moles is 1.25 molarity. I mean, not number of moles. The molarity is 1.25. I keep saying moles, but you know what I mean. I mean this, molarity.
Yes.
And the number of liters is 0.345 liters, as we figured out up here. Martin will do that calculation on the calculator.
Calculatron, please. Okay, it's 0.43125. So that's
okay, we want to have three significant figures. So 1, 2, 3. 0. And what is this unit?
Moles.
This is going to be moles. Okay. So if I use 345 milliliters of 1.25 molarity aluminum nitrate, I'm using 0.431 moles.
Yeah.
Since I can figure out then how many moles of that am I using? It's 2 to 1. So I'm going to divide this by
2.
That will give me
0.21555.
16 is what I'm going to call it, because I only want to use 3 significant figures of that. Okay, so I have 0.216 moles of aluminum sulfate. Okay, how do I translate that to grams? Do you see that? I think so. How do I translate 0.216 moles to grams?
Well, we need some AMUs over here.
Right. So I have to figure out the molecular weight of Al2SO4. So Al
is 27.0.
Is 27.0 times 2 is 54.0. Okay.
Well,
we have 3 S's.
Actually, S is 32.1.
What do you mean? I didn't do S yet. I'm only talking about the AL. You said AL was 27.0, right?
Okay.
54. Okay. S times
is
3. What's S?
32.1.
2.1 times 3. That's going to give me 96.3.
Yeah.
Okay. And then O is, how many O's do we have?
16.0.
Stop. How many O's do we have is what I asked.
5. 4. 4 times 12.
Yes, we have 12 because there's 4 in each sulfate and there's 3 sulfates, right?
Yeah.
So it's 12. So it's oxygen times 12 is 16.0 times 12, which is what? It's 160 plus 32 is 192, right?
Yeah.
And we can keep the tenths there, okay? Because this is just, it looks like multiplication, but it's really addition, right? We can say precise to tenths in all of these numbers. So we have 0.3, that's 10, 12, there's 1, that's 10, 16, 25, 352.3 grams per mole, right?
Yeah.
So how do we find out how many grams? We have 0.216 moles times what conversion unit will give me grams?
Grams per mole.
So that's going to be what? 352.3 grams per 1
divided by
mole,
0.216.
right? No, please look at my math. You're not dividing, you're multiplying. You have to set it up.
Right.
If you don't set it up on your paper, it's likely you'll do the wrong calculation. 0.216 times
0.216. 76.0968.
How many significant digits should we be keeping?
3.
Okay, so tell me.
76.1.
76.1 grams. Okay, we're going to pause here and come back with another video. Thanks for joining us.